So, satellite is another topic, and we are interested in looking into the satellite basics. So, satellite and the escape velocity. So, this the proposition is that the absolute potential energy is equal to the kinetic energy. So, the absolute potential energy is equal to kinetic energy. Absolute potential energy, as we know, which and we will derive this for an object around the Earth is gme by re, where me and re are the mass and radius of Earth, and capital G is the gravitational constant. Gme m by re, and kinetic energy is the half mv square. So we can equate the two. Half mv square is equal to gmem by re. M cancels out with m on the other side, so v square is equal to gme by re. So v is equal to gme by re, okay, under the root. So this is the first thing here. mm, 2 gme by re, 2 gme by re, okay. And as we know that in the situation with gravity, F is equal to mg, and mg can be equated to um, gmem, mass of Earth and mass of the object, by r square, or re square in this case, radius or radius of Earth square in this case. Okay, and what we get basically is small m cancels out, so re dot g is equal to gme by re, okay. So now we use these forms. Reg is equal to gme by re, okay. So 2reg is equal to 2gme by re. Is that so? Yes. Okay, so okay, let's make this one here, and let's make this 2 here, okay. 1, being slow because I'm trying to avoid the error here, and 2. And so 2 gme by re is equal to v square. Okay, so v square in this case now becomes 2reg, or v becomes 2reg under the root. Okay, or v escape can be, the escape velocity of the satellite can be 2re dot g to the power 1 by 2. So this is the form we are looking for in general terms. Yes, sometimes we have to average out the force, which makes the initial force to 0 to begin with, and the final force, and then 0 plus f by 2 becomes the average force, which becomes f by 2. So these are the conditions or approximations which you are supposed to take in some situations, but everything depends on the possible approximations. So this is very much the form for escape velocity, if I'm not wrong, but we will look into it later on. Linear and angular momentum. Yes, linear and angular momentum. So linear and angular momentum. We develop the forms, and the preliminary ones are s is equal to r theta from the segment of the circle, the radius and the angle multiplied give us the length of the arc, and s is also the distance covered in terms of velocity and time. So we equate the two. This is 1 and this is 2. So vt becomes equal to r theta. V is equal to r theta by t. Now omega is equal to theta by t. Angular displacement by time is equal to angular velocity. So now if this is 3, then with the substitution it becomes v is equal to r theta by t. So v is equal to r omega 4. Linear velocity in terms of radius and angular velocity. Okay, and acceleration. Acceleration is basically the final velocity minus initial velocity by the change in time or time. So omega f r minus omega I r by t. Yes, the angular velocity final into radius minus angular velocity initial into radius by time. So a is equal to r by t into omega f minus omega I. So initial final minus initial angular velocity is equal to delta omega, or change in angular velocity, and that by time would give us angular acceleration, which is alpha. Yes, so a is equal to r alpha. R alpha is equal to a, and also And also, since in a circle linear velocity is tangential, radius is perpendicular to velocity, so this theta is 90 degrees, and sine of theta is 1 in this case, because radius is perpendicular to velocity. Initial condition here, radius is perpendicular to velocity, angle is 90 degrees, sine of angle is 1. Okay, so in terms of the vector product, if we take this r alpha sine theta and approximating with the circular arc, we get a is equal to alpha cross r. Yes, alpha cross r. Changing the sequence. A is equal to alpha r and A is equal to alpha cross r. Yes, and the vector product AR is alpha r sine theta, and then is alpha cross r, because theta is 90 degrees and sine theta is 1. Okay, we approximate it with the circular arc, and there's one more thing, that A is equal to r alpha, for example, in scalar form, and then V is equal to r omega. Mm-hmm. So we resume with the linear and angular acceleration. To make a correction, it is about linear and angular acceleration, not momentum. So A is equal to r alpha, where A is the linear acceleration, alpha is the angular acceleration, r is the radius of the circular motion. Okay, and so we take into account the centripetal acceleration and centripetal force. This is important. Centripetal acceleration